G'day everyone, this is lesson 2 in our series on soils, and today we're looking at soil chemistry. So there's going to be 4 parts of soil chemistry that we're going to look at, and really we're now getting down to the nitty gritty about, I guess, the components of soil and how they all react with each other. So a lot of these properties of soil all come from the original rock or source material. When that material combines with the atmosphere and water, we get chemical reactions going on. And sometimes, as you know, when there's a chemical reaction, sometimes things happen. For example, colors can change, or even heat can be given off. So let's look at some of those reactions that go on in soil and make notes of them. So I guess we're going to say that the reaction of original source material with, should say rock by the way, with water and the air. And these are chemical reactions that go on in the soil. Sometimes when chemical reactions, well, we think about what happens. Sometimes you have a color change. Sometimes you might have heat given off. Sometimes you might have a gas produce, and many other types of results of chemical reactions. So, first one I'm going to look at today is ion exchange. So this happens in soil, and as you guys know, when you have an ionic compound, they separate in water. So for example, salt, sodium chloride, well, in water, it separates to its 2 ions, a sodium ion and a chlorine ion. We generally call this a cation, definitely don't call it a cation, and an anion. So ion exchange is the movement of some of these positive cations and ions through the soil. All right. Generally, and clay is something that not only in real life it's very sticky, but chemically it can be very sticky as well. And cations will stick to a clay surface and accumulate. Actually, clay surfaces have been linked not only to attracting cations, but attracting early organic particles or inorganic material, causing I guess for some, the formation of early cells. So clay itself, cations can stick to it. And you'll end up with a soil that is positively charged. Why? Because the cations have generally stuck to those clay particles. So soil can be positive charged. And a soil that's positive charge can actually change the amount of nutrients that it can hold. So soil that's positive charge will actually be more fertile. So why a positive charge influences the amount the way nutrients move through the soil. So more charge equals more fertile. Less charge, less fertile soil. What does it come down to? A little buddy clay. Hope you can see clay written down the bottom there. Good. So that's ion exchange. Let's draw a little line down here. Let's move on to our next one, and that is the wonderful pH. If you know what pH stands for, please tell everyone else. I know what it means, but I think everyone, or most guys should know. If you don't know, please look it up. No, I don't even want to give you a clue, but it's... look, pH, though, is the measure of soil alkalinity or acidity. Alkalinity or acidity. Soil that is between 0 to 7 on the pH scale is acidic. And soil that is between 8 to 14 is alkaline. Soils generally range from 4 to 0. Sorry, 4 to 10. pH is important for plant growth. I feel like giving you a clue. It's power of something. So if you're still wondering what pH stands for, I think I have to leave you to look after the rest yourself. So pH is important for plant growth. It affects the amount of minerals in the soil. One such mineral is iron. Iron becomes less available to plants as pH increases. And if you have less iron available, we end up with an iron deficiency. Let's go down to what controls it. controls it? Well, it's controlled by water. It's controlled by water movement, as well as so certain organic material can make soil more acidic or more alkaline. Most organic material will create what is called humic acid, which obviously that breaks down to a more acidic soil. Sometimes if you have a source rock that perhaps could be more of a carbonate, we end up with a more alkaline. Someone asked me once that they have a soil that is very, very alkaline, and they wanted to try and make it more acidic. And so racked my brain, and I actually found that if you use coffee grinds can actually start creating help make the soil more acidic. I know that in some places where there are a lot of pine trees, the soil can be extremely acidic because of the nature of the organic material that's there. Okay, there is a little graph that I can demonstrate this with. I'm just going to draw it freehand. It's not going to be very good, but let's have a little go here. I hope you can see we've got the availability of the elements, and we're thinking of iron, etc. And let's draw a little arrow going up there. We're not going to put any marks on this, and here we'll put 4. This is our pH scale, 6 and 7. So if we think about the availability, I should say, of iron, as pH increases, its availability of iron decreases. Conversely, with some other elements, let's say, for example, calcium and magnesium, well, they're slightly the opposite. Their availability increases with pH, calcium and magnesium. So the pH can be good for some elements and bad for other elements. Obviously, a higher pH is not good for iron, but conversely, a good pH for calcium and magnesium is a lot more acidic. Is a lot more alkaline soil. If we think about elements such as nitrogen, it's a little bit more steady. I'm going to draw here. This would be where nitrogen is, and nitrogen is very, very important, as is sulfur, which forms on the same line. So the pH will control not so much whether plants dissolve in the soil, but it controls the availability of these elements, which help the plants to grow. Okay, let's continue and let's move on to our others. I hope I've got some more room over here. I should have enough to finish this off. Let's start looking at now the organic matter. Organic matter. So, organic materials can actually change the colour, and they store nutrients in the soil which are used by plants. So what is organic matter? Well, It's just any material derived from the decay of plants and animals. So it's any material derived, I didn't see plants there. Derived from the decay of plants and animals. And what does it contain? Nitrogen, carbon, sulfur, phosphorus. Bushfires actually play a really important role in reducing the amount of organic matter. Why is that? I guess that's a question I'm going to leave for you. In Australia, bushfires control availability of, so that's availability there, of organic matter. How do they do that? Please think about that. How do bushfires do that? Okay, let's go on to the last one. Our last little bit of chemistry, I guess you could say. I'm going to do this in blue, and this is oxidation. What's the opposite of oxidation? Or reduction. So back to year 10 chemistry here. As soils alternate between wet and dry, they go from a lot of oxygen to very little oxygen. From lots to very little. And the presence of oxygen really determines how soils will react. Oxidation, we think about oxidation, that's a loss of electrons, and reduction is the gaining of electrons at the surface. And this oxidation, well, look, primarily, what does it change? It changes the stability of the soil, but it also leads to that, obviously, that massive colour change. So let me write some of that down. So presence of O2 determines how soils react. So a change in soil structure and colour. So I wanted to, I guess, talk about one rock, and that is basalt, my favourite rock. So basalt contains iron. A soil that's made from basalt has a lot of clay in it. It'll react. To make a colour change. To change colour. What colour will it change to? Yellow, orange, or red? All right. I'm going to finish with a couple of questions for you, and I'll get you guys to have a go at answering them. And I just sort of came up with these in my head a little bit earlier. Hopefully they'll be good. I want you to identify the two most abundant minerals in our two most abundant rocks on Earth: granite and basalt. So that's the first thing you're going to do. You're going to have, so you'll end up with 4 minerals, or maybe 3. Then, for those minerals, I want you to write down the chemical formula of them. And have a look at them. Have a look at the differences between those two particular rocks. This is something that we'll talk about a little bit later on. We'll definitely talk about this in year 12, but the differences between these two rocks come down to these minerals and the chemicals that are within them. So the final question, after you've got those formulas, I want you to say which elements are most likely to react with oxygen in the soil. And what color will you get? What will change? All right. That's it, cats and kittens. Don't forget to like and subscribe. No, don't like and subscribe. I don't care. Also, look, try and talk to your friends about this. Talk to your parents about this. Get them interested in soil. Go home, dig a hole, have a look what's in there. And have a look at the soil itself. You'll notice that soil is not just particles of sand. There's a lot of other stuff in there. That's it for today. Have fun with those questions, and I'll see you all soon. Bye.